I'd like to first thank Lavastorm for sponsoring today's webinar. Lavastorm has been a longtime supporter of the Data Science Central community, and we are honored to have them supporting today's event. I would also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including EMC Greenplum, Alpine Data Labs, Tableau, Hortonworks, and Splunk, to name just a few. These past webinars are available on demand at datasciencecentral.com, and if you've not had the opportunity to view them, I would encourage you to take a look, as they do provide some very good perspective and insight into our industry, specific to the topics discussed. Today's webinar is entitled Combining Big Data with Enterprise Data to Improve Business Performance. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We will have 2 panelists that I'll introduce to all of you in just a moment. We should have about 15 minutes for Q&A following the presentation. And you can find this recorded event on datasciencecentral.com in about a week. I would encourage all our attendees to provide questions directly to me throughout the presentation. I will be reviewing them and presenting them on your behalf with the time remaining after the presentation. My name is Tim Madison, and I am one of the co-founders of Data Science Central, and I will be your host for today's event. I'm very pleased to introduce today's speakers, Brandon Smith of SippyOn Solutions and John Joseph of Lavastorm. Brandon is responsible for leading SippyOn's strategy and growth. Prior to co-founding SippyOn, he served in a variety of executive roles, leading the delivery of mission-critical enterprise data, analytics, and process optimization solutions for both U.S. and international companies. John is the Vice President of Marketing at Lavastorm and runs the marketing organization at Lavastorm Analytics, and is responsible for tracking industry and customer trends in the analytics market. He brings more than 15 years experience developing and bringing game-changing software products, including Agile BI and SOA integration products, to the market. John and Brandon, thank you for both joining us today.
Thanks, Tim.
Thank you, Tim.
In today's webinar, you will learn the following: how big data technologies such as MongoDB can be used to store and access data from non-warehouse sources, such as financial trading systems, the speed advantages of using MongoDB, pardon me, all right, sorry about that, the speed advantages of using MongoDB over Hadoop for near real-time analytics, techniques for integrating the results of big data queries with traditional enterprise data on near real-time or real-time basis to instantly benefit the organization, tool and data management strategies that will allow you to reap the benefits from both the vast scope of big data and the contextual information of enterprise data, and finally, techniques for both presenting big data solutions to the decision makers. John and Brandon, thank you again for being with us today. And John, I'm going to hand over the control to you, and okay, you can proceed.
Thank you, Tim. Hopefully everyone can see my screen now. Again, this is John Joseph with Lavastorm Analytics speaking. I'm very glad to be here today with Brandon. And I'm just going to take 5 to 10 minutes to set the stage for Brandon. SippyOn is doing some great work with MongoDB and big data. And I wanted to take a few minutes just to talk about the opportunities that Lavastorm Analytics sees coming from big data, and also talk about the challenges that we see out there. It's important because we think SippyOn is actually now doing a great job of solving some of those key challenges. So first, I wanted to highlight that what we've seen dramatically change over the past few years is that Businesses today are competing much more heavily when it comes to on analytics and their ability to understand the dynamics of situations and what is taking place in the market. And it's not just the Googles of the world or the eBays of the world which are measuring everything. It's traditional businesses, web communications companies, healthcare organizations, utilities, everybody. Analytics has become a way to separate yourself from the pack, to service your customers better, and understand how to make more money. What we see, the reason for that is that businesses need to react faster. And it's not just the people in the sales department looking at sales data, but they need to go one level deeper than that to understand why things are the way they are, why are sales dropping, how to make improvements, and that all starts with having greater visibility, faster access to the information, etc. One key element to why this is the case is that the demands on businesses have changed because customer expectations are quite different. And this all started with the onset of the internet and online shopping and things like that. But if you look at customer expectations today, it's incredible how it's changed over the past decade. Today, it's demanded that businesses respond faster, understand their customers better, and have more specialized products and services offerings for customers, even down to the individual level. And that's what's pulling the need at least one of the factors pulling needs to analyze the industry and market conditions more precisely for the businesses. Another factor that's changed how analytics is looked at by businesses is the complexity involved. So what we like to point out is it's not just more data, which is what people like to think about when they think about big data. But there's certainly more data coming from all different places. There's new data sources that didn't exist before. There's also more of a need to have more decision makers, so pushing that information out to people that can actually use that on a daily basis. And there's more change. And so relationships are much more fragmented. You might have many more partners than you did a few years ago. You might depend on those partners more heavily. You might have more integrated systems with them, etc. Change is a part of life, and the complexity involved of trying to understand the entire value chain has never been more important and never been more complex. So all of that added up means that organizations have to take a different approach to analytics. In the past, it was probably enough to look at information that was stored within your own walls, usually stored within a silo of data focused on one part of your organization, and kind of optimize around that information sort of within the department. But to improve results today, and SippyOn and Brandon will talk about this in detail, it really calls on bringing in data from outside those traditional warehouses and data stores. And that's essentially, it's a good way to think about big data, because it's not just the volume, like I said, it's the variety and different types of data that are now being included in the analysis to improve the decision making. So first, one of those areas that's really important is to bring together those silos that you may have been working with for quite a while, but to bring them together in a way that that you can look across business process that cuts across those departments to optimize business performance that way, not just one department. But also data might come from outside your company. It might come from third-party data, such as government data, or from those partners that you go to market with. It could include enterprise data within your walls, but information that is too voluminous or too complex to put into the data warehouse. They include things like your some information from your CRM system or machine-generated data. There's really no limit there. It might be engineering data, etc. Also, it could include unstructured or semi-structured data, documents, things like customer surveys, and it could be from new data sources entirely. Social media has been talked about a lot. There's some good proof points there, but it also could just be a wide variety of data that's accessible to you now through technologies such as MongoDB and Hadoop that allow you to tap into these very large data sets and make use of it where it would have been too difficult to do that before just because of the sheer volume of things. So tapping into these new resources is really the trick. In terms of opportunities, why is this important and what is it worth? I'm going to highlight something from McKinsey here, which they talked about companies using big data and analytics have productivity rates and profitability that's 5 to 6% higher than those of their peers. So that's a huge improvement, especially if you're talking about retail organizations and organizations like that where margins are quite thin. So it's clear that there's huge potential to big data. If to paraphrase some research analysts at Gartner, we can look at big data opportunities as being 3 types of opportunities, how that breaks down. First is to discover new things, hidden insights. And from our experience at Lavastorm Analytics, we see organizations, as an example, moving to things like real-time fraud detection, where they're monitoring fraud cases more in real time than ever before. And to do that, they're bringing together many more data sources than they've ever done before. So one organization, for instance, is bringing together 60 different data sources, tying them together to try to identify those fraud cases more quickly, but also with greater resolution than they've ever been able to before. The next opportunity is to use big data to transform or automate some processes. And I think a good example of that from our experience is we see different data models popping up. So one example of that is a communications company that implemented a pay-by-the-drink billing solution. And so you don't just buy like a monthly plan, for instance, but you actually pay per transaction. So you can just imagine the volume of transactions is much greater, the complexity is much greater. You might be tracking transactions across different time periods, across different platforms where they may have been executed, et cetera. All includes new data sources and much greater volume to make that possible. And that's made possible by harnessing these data sources. The final type of improvement, opportunity from big data, is to just make decision-making much more visible, much more richer by bringing in data that gives you a wider scope, a better perspective on how you're making your decisions. I think there's a lot of potential here in terms of improving your ability to service your customers. One example from our history is a customer that was implemented a pretty widespread customer surveying tactic to survey customers at different points in the relationship, not only at the installation or when they made a complaint, but all along the relationship if they passed different milestones, if they surpassed certain spending levels, if they reached certain anniversaries, and trying to use that information to understand the impact of those events on the relationship. And that required bringing again new types of data into the fold and using that to improve and optimize various business processes within the organization. So those are the opportunities and some examples of where you might find them. It's important to note, though, that there are challenges, and it would be a mistake to think that simply by bringing in new data you can automatically get great results that you didn't get before. It's not as simple as that. First of all, big data can be quite large, and so the trick is finding those opportunities within the sea of information that's in front of you. If you look at if you look at some surveys on organizations that are tapping into big data, some of the challenges that are out there that have been identified is the first one is data integration and data quality. You're bringing together data from different places, had a different history, different creation mechanism. They're really cats and dogs that you're trying to get to live in harmony together. And so building an infrastructure that can handle that complexity, and data quality is a big part of this because some of the data is coming from your enterprise, some of it's coming from outside your organization. You may have to improve some of the data, implement some data quality checks, improvement mechanisms, et cetera, along the way to make it all fit together. And so that will help you build trust and get a consolidated view of these different sources. So that's one challenge that's in front of organizations. The next challenge is the skills involved to make it all work. We at Lavastorm Analytics actually did a survey of more than 600 practicing analytics professionals on analytics in 2013, the state of analytics. And one of the challenges that came through in that was the skill level available. So we clearly need, if we're relying more on analytics, we need to have more capacity to conduct the analysis all along the spectrum. So bringing the data together, creating the analytic applications, looking at the data to find the new insights, and publishing the results, and then acting on the results. I mean, there's a whole spectrum there of analytics. And so we need people, either we need more people that are trained on how to do those parts of it, or maybe more importantly, we need the tools that make that hurdle of harnessing the data much more approachable to a wider audience. So that's the second challenge. And the third challenge I wanted to highlight is ROI. And I'm hearing from people that some organizations are struggling with ROI. I had a reporter ask me recently, why are people grumpy about big data? And honestly, from our experience at Lavastorm Analytics, we don't see that. But I do see the potential for that happening because it is a wide universe of information you're trying to pull together. If you approach it with your eyes shut, you can spend a lot of money and you can spend a lot of time on it, but not fruitful time. So I think the key for ROI is to have the right tools and right approach that you can do exploration and discovery at a low price point and low risk level, so that you can find the potentially valuable nuggets and then invest more on those as you see the potential there. So getting that ROI, positive ROI, is important. And again, I think it takes the right tools and the right approach in order to do that. I just want to introduce you to Lavastorm Analytics and our analytics platform, which will be highlighted by Brandon in his discussion of their solution. We offer the Lavastorm Analytics platform. It's a platform that was built from the ground up to handle big data, especially the variety of data. And we allow you to bring in data from all different sources, put it together very, very quickly, 90% faster than other ways, such as using SQL. The key there is that there's no overarching schema or design that's necessary for planning all the data ahead of time. So you can join the data together and just go. That solves the data integration challenge that we highlighted on the last slide. We also have, it's a visual tool, so you can create logic very quickly and with great visibility. Some of that logic within the interface can be used to improve data quality right at the get-go, and can be the process. It can be a visual model that implements data quality checks and improvements so that you can bring all of this diverse data together in a nice package and actually show that to other people so you can build trust within the data. When you get the data together, you can use it for discovery, so you can quickly look at different hypotheses, evaluate whether there is potential there. That helps with ROI. And because it's a visual tool, it lowers the hurdle for skills that we mentioned on the last slide as well. And finally, with a visual model created with the Lavastorm Analytics platform and its Lavastorm Analytics engine, which is the core of it, you can deploy any analytic you create to be a long-running process to make sure that your analytic insight is put to use within the business as a continuous analytic control. That helps with ROI. We also have automated resolution capability as well, which again helps with ROI. So your analytic doesn't become a dead end. It actually gets tied back into the process and the people that are within the business and in the middle of the trenches working on delivering the service and products that you offer. Just briefly on Lavastorm Analytics, and then I'll turn it over to Brandon. We have been around for more than 15 years, and in fact, 451 Research pointed out that we were in big data before it was cool to be in big data. So if you look across our history, we've worked with many different organizations, really a global customer base. What we give them is the ability to process data in a new way, a new agile way, that they can analyze data, optimize processes, and control their processes. And over that time that we've been in operation, we've generated billions of dollars in value, either new revenue sources, better business models, things like less fraud, which help you control costs, et cetera. So we've done, as a result, been in a good seat to see how big data has evolved and matured over the years. Now I'm going to turn it over now to Brandon Smith, who's CEO of SippyOn. And I'd like to introduce Brandon. You heard his bio before, but just to elaborate on how we work together. SippyOn is a partner of Lavastorm Analytics. They actually selected our Lavastorm Analytics engine as a key element of their reference architecture, which they call the answer factory. And one of the reasons that, I'll let Brandon elaborate on this, but I think one of the reasons that Brandon and his team selected the Lavastorm Analytics engine is that we do make it possible to bring big data into the business and use it to improve business performance. Specifically, we help lower the cost of big data integration. We give more decision makers access to the information so they can take advantage of those benefits. And in his words, we help operationalize big data, bringing it closer to the processes by tying it to other data that you have within your business. So with that, I will turn it over to Brandon, and I'll see you in the Q&A session for any questions that you might have.
All right, thank you, John.
Brandon, you should have your screen up by now.
Sure, yeah. So, John, thank you, and just wanted to really quickly give you an overview of SippyOn. So we're focused on providing solutions that are really designed to analyze, optimize, automate, and control business processes. And specifically, we're focusing on kind of the second-tier business processes, so we don't look at the mission-critical applications that are necessary to run a business, but kind of the systems below that traditionally get neglected and don't take advantage of emerging tools and technologies in a way that they can really improve how they, one, drive their data strategy. So in other words, using data as an asset for the business as opposed to just a byproduct. Take advantage of all the different data sources that are out there. So for example, we've integrated unstructured data, documents, emails, things like that, and coupled that with big data tools as well as traditional data sources. And then finally, we really focus on providing data that the business user can interact with to improve how they're making decisions and driving results within their company. So in terms of how we target our solution, this is going to be somewhat repeating what John said, but it's important, I think, to kind of set the stage. If you think about how business users are using data today, it's very, very different than how it was even 10 years ago. So your typical business user is much more sophisticated around the use of data, around how that data can be used to really drive behavior and drive operations within a company. Tons and tons of data out there. So everything from your refrigerator all the way to traditional data sources are producing data. And so the volume of data that's out there for improving how you make decisions and such is completely different than it was even last year. And then finally, organizations still are very siloed. So you have finance ops doing work within their financial organization, marketing doing their own thing, and then of course sales is doing their own thing. And so what happens is that you don't necessarily have all the pieces connected together. And what that leads to is what would traditionally be a centralized IT function becomes highly decentralized, and you have business folks out there doing their own sort of IT type of work. And so to address that, we've invented Answer Factory. And Answer Factory is an enterprise-grade application that is designed to support any type of data and any type of process and do it very, very quickly and in a way that provides what are normally very complex tasks around data in terms of doing correlation analysis, making it much easier. And this is really a key to why we selected Lavastorm. And I'll be able to show you this in just a second. But the end result is that we're empowering business users to manage and access their data in a way that doesn't require the traditional IT cycle of several months or several years to get a solution in place. So in terms of big data, and again, this is just to kind of set the perspective of what we consider big data. And if you ask any database vendor out there, they're going to give you their own definition. And even if you ask consultancies, and so there's really not a standardized term about big data. So the way we look at it is big data really just describes a way of storing, analyzing, and accessing data that breaks traditional databases / infrastructure. And I'd also add to that breaks the ability to use existing resources, human resources, to do the type of work that needs to be done on all these massive data sets that are now out there. So some of the challenges, as web designers were scarce in 2000, you had the same problem with scarcity of big data experts. So as John was kind of mentioning before, it's important to kind of take advantage of tools that can simplify that learning process. Second challenge is that you have all this data, so what do you do with it? So it becomes a situation where it's almost drinking from a fire hose. So how do you manage that data in a way that it becomes useful as opposed to just overwhelming the business with the amount of volume that's out there? And then finally, the technology is still new, and therefore some of the ways of accessing that data are still overly complicated. So if you ask any practitioner of big data, they're going to tell you that their number one headache is around MapReduce jobs. And MapReduce jobs are very, very powerful, but they're also very complicated and very difficult to master. So when we were working with one of our customers who was a top 3 retail trading firm, they asked us to come in and do a market data assessment and do it in a way that their traditional approach couldn't handle. So this goes back to exactly our definition of big data, which is that it's dealing with data that breaks existing processes or you don't have the folks internally to be able to manage. So what they've asked us to do was to come in and basically identify bad trade fills. And a bad trade fill is where someone has bought a stock, for example, at a price that was higher than what they could have bought it for, or they sold it at a price that was lower than what they could have sold it for. And so that allowed them to basically go in and report those bad fills and take corrective actions with their partners. So basically go in and figure out exactly what's happening and then do any sort of remedial action to address the problem and report on it. The second need was to quickly assess changes in, quote, mid-price. So mid-price, if you think about that, it's basically the middle of between what the stock price is, what you could buy it for, and what you could sell it for. So if you could buy it for $1 and sell it for $1.10, the mid-price would be $1.05. And so what that allows them to do is get insight into the volatility of the market and how that impacted overall trade performance. So now we're dealing with a very, very large amount of data and doing it in a way that they can instantaneously make adjustments to their business. So what led us to MongoDB and Lavastorm? So we did quite a bit of work at looking at the market and trying to identify what is the best sort of tool set out there to do this type of work. And so the first thing is it had to support random access. So MongoDB in particular is very, very good at query capabilities. So we wanted to be able to basically dynamically ask MongoDB, give me the results for these particular stock quotes and trades, and give me the results back. And although you have tools like Hide this and on top of Hadoop, MongoDB is really optimized for random access. So point there. Second thing is we didn't need to do complex data analytics. So we didn't need to do a lot of predictive analytics. We didn't need to do statistical analysis, things like that. So we didn't have a need to do these very complex MapReduce jobs. So we're able to do a lot of that within Lavastorm. We couldn't put everything inside of MongoDB. There was a number of data sources that we had to pull out of legacy systems, so we needed to be able to correlate the big data tool that we're using, in this case MongoDB. We had to be able to correlate that with existing legacy systems, and so that's why we selected Lavastorm. And then finally, we didn't want the complication of doing everything using MapReduce jobs. So where possible, we were able to basically take what we'd have to do in a MapReduce job and do that inside of Lavastorm. So it kind of simplified and accelerated the development process of doing this analysis. A bit more detail about the solution that we put together. So we're taking market data, so basically all the U.S. equities, quotes and trades. We did this for a period of a couple of months, so you're talking about, several 100 million records. Trade data, these are the actual trades that the retail trading firms' customers are making. And then various information about the customer's portfolio, or the VIP customer, or the high-frequency trader, those kind of things. And from there, we loaded that into MongoDB, and then we used Lavastorm to analyze that data against the various operational data sources that we're using to produce exceptions and things that we wanted to actually manage. We took those things that we wanted to manage and put those inside of our user interface, and then we had a web-based front end that allows the end user to do business intelligence and workflow on top of that analysis. What that led to was the ability to really take what's normally a byproduct of the business, equities, quotes and trades, and use that to really drive how they're looking at their business. By taking this approach, using a MongoDB coupled with Lavastorm, coupled with our own product, we're able to do it at about a 75% cost reduction from what they would have to do internally. Also, very, very importantly, it was able to be implemented 80% faster, and it's a repeatable, scalable solution. So it's not something that they did one time and threw away. It's something that kind of lives and breathes and now is part of their organizational and operational processes. So with that, I'm going to go ahead and jump right into the overview or the demo of Lavastorm's analytic engine. And this is just a tool that you could use to define and implement the business rules. So in this case, you have the canvas here, which basically allows you to drag and drop various units of work that are fully documented by themselves to start to assemble a solution that allows you to take a very complex problem and decompose it into its individual steps in a way that makes it very easy to, one, make sure that your results are correct, but also to validate directly with the people that understand the data best that this is what you're in fact trying to do. If you notice down here at the bottom, there's a number of library sources that are available that allow us to do things like acquire data, so we can take data out of traditional databases, or in this case, MongoDB. You have the ability to aggregate and transform data, to correlate it using joins and cross-references, things like that. A number of custom libraries that we've built to query directly from MongoDB or to MapReduce jobs, and profiling data. So there's a very, very rich set of data that's available for doing analytics. And in the event that there's something that's so custom that you can't do directly with one of the existing assets, you can actually extend this in a way that makes it pretty much configurable to any sort of business solution. And so if you take a look at the graph here, kind of working left to right, what we're doing is the first thing is that we're taking trade data that's coming out of the operational system. So in this case, we're taking about 82,000 trades that we want to analyze. And this happens to be coming from an Excel file, but it could be from a database or anything else. And what I could do is I could double-click on this output and directly see the results of the initial import of data. And so from here, I can do sorts. I can see if it's on the buy side or sell side, base it on the time. And so just by pulling data into the application, you start to get the ability to do a type of analysis that you may not have been able to do before. From there, you can start to wire these different operations together. So in this case, we're going to wire the trade data directly to this filter node. So in this case, for the demo purposes, I just want to pull out one particular trade so I can show you how it kind of works the way through the system. And if you notice here, there's text here that fully documents exactly what it is that we're doing. What I could do is double-click on this filter node, and it's going to pull out a listing of the overall business rule that I set up to filter out this one particular trade. So in this case, it's almost like SQL. So if you've used SQL, then it's something that kind of is easy to pick up on. But we're basically outputting all the data where the issue being the same thing as a symbol, is equal to COP, and the order time is equal to this. And we're talking about a financial services problem here, but really this can be applied to any type of data. It could be trade data, it could be call detail records, it could be healthcare information, whatever. So the general approach is generic enough that you can actually apply this to lots of different data problems. And then from there, just kind of, again, working left to right, I'm doing some cleanup of the data. So in this case, I want to fix the dates and times, or dates and amounts, rather. So I'm actually making a real date as opposed to a string, which is what it came in as. Again, this is a really good example of where I'm taking the data, and I can see that everything is a string here. And then when I look at the output of that, I've got my new data that's transformed into a format that's useful for doing other analysis. So I've got a date time and a double here. So it's a way to basically take the data and start to transform it as you go along each one of the steps in the overall analysis, and then do it in a way that's pretty much self-describable and documentable. So up to this point, we're still dealing with the legacy data set. And then what we're doing there now is we're actually taking that legacy data and we're pushing it directly into MongoDB using this this node that we created. And so if you look at this particular filter node, what I'm doing here is I'm just grabbing the two columns that I care about, in this case the issue and the order date and time. I'm pushing that into Mongo, and what this process does is it actually goes out and it's going to find all the quotes and trades that happen plus or minus 5 seconds from when that particular quote in time trade happens. So what we're trying to do here is essentially find out what the market was like 5 seconds before and 5 seconds after the trade was made. And then that's going to give us 11 records that we want to drill into to do additional analysis from. So again, this is coming directly out of MongoDB. And so we're taking legacy data, pushing it into MongoDB, and then MongoDB is giving us a result set back that we can do additional analysis on. And so again, this just has a bunch of trade information that that we could use for additional analysis. So the next thing I'm going to do is I'm going to double click on this compile data node, and this is a special type of node called a composite node. And this is one of the great things about Lavastorm that we really appreciated and liked when we were selecting an analytics platform, is that it allowed us to really manage the complexity of very complex processes. So if I double click on this, it's going to allow me to drill down into additional details behind analyzing this data. So got some additional steps here where we're taking out duplicates, we're doing some deduplication, things like that, some additional normalization, some sorting. Again, that specific's not very important, but then here we actually go into another composite, which is really where we're starting to do a lot of our analysis. So if I double click on this, what it's going to do is it's going to give me another layer that I can go down into, and I can rerun this part of the graph, and it's going to allow me to basically do it as a checkpoint. So everything up to this part of the process, I don't have to worry about rerunning. So my queries to MongoDB, my queries to my legacy systems, and all that are already in place. And so by rerunning this one part here, I can iterate on the analysis of this one particular part of the application in a way that if I were doing MapReduce jobs, I'd have to rerun the entire MapReduce job. So this part alone saves a tremendous amount of time in just the analysis of the problem. And so in this case, what we want to do is we want to get all the specific trades that happen plus or minus 5 seconds of when a particular trade happens. So this first node is called a cross-reference node, and what it does is it basically takes two data sources and joins them together based on the keys that you specify. So in this case, I've got an issue. It happens to be called an issue in one place, a symbol in another place, and then I've got an order time on one place, and then a quote time on another place in the other data source. And so what this is going to do is basically allow us to do all three join types at the same time, the left inner and right joins. And each one of these outputs indicate the results of that left inner and right joins. And so the one I really care about is this inner join. So we'll get back to that in a second. But, so this is where the quote and the trade matched exactly. And then if I want to go through and look to see where there is a quote that happened the second before, the second after that said, these two particular operations. And the way that we've done that is we've just used a built-in script capability called data time adjust, where we added 1 second to the order time that was on the actual quote. And then we grabbed that same quote from MongoDB using the 1 second offset. And then on the other side, the 1 second before, it's just we subtracted a second. So very, very simple sort of scripting language that gives you a lot of control over how you express what would normally be complex logic. And then so what we've done then is we've taken all those different outputs together and built essentially 11 individual records that correspond to each one of the different trades that we have here, or each one of the different matches that we have here. So the exact match, the plus 1 second, minus 1 second, so on and so forth. And then if I look at that data, what you'll see is I've got for each one of those trades, I've got a list that has each one of the specific values that I care about looking at. So and then I've got a lot of obviously places that aren't populated. So the way I deal with that is if I go up a level here, we've got these two nodes here that basically will collapse all those individual records into a single record for that given trade that I'm looking at. So to run that, just go and kick that off. And if you notice here, I went down from 11 records down to 1 record. And that 1 record will have a collapsed view of all the T-5, T-4, so on and so forth, all the way to the T+1. So it basically creates a single record that we can use to do analysis on. And then I've taken that same sort of process and I've sent it to 2 different paths. The first one is the best execution path. So this is where we're looking for trades that were sold or bought at a price that was not favorable for the customer. And then on this other one, this return profile, this is where we're looking at the market volatility. And so in terms of the best execution side, basically what we're doing here is we're just going through and running additional analysis where we're splitting out between the buy side and the sell side. We then identify where the sold point is lower than the midpoint. And so the way we've done that is we've just said, okay, at the exact time that the trade happened, what was the price? Was the price higher than what they could have bought it for? And then from here, we're going through and we're just doing another call to MongoDB. So this is where we've taken data that is now kind of a combination of both the operational data source as well as the MongoDB data source. And we're taking that and then applying that again to MongoDB to get the actual trades that we want to go in and look at, see what the market was doing up to that point. So this by itself is a very useful research tool that if you have an exception or something that you really want to drill into, you could do that here. On the other path, where we're looking at the volatility of the market, the way that we've done that is we are essentially going through and we're looking at basically what the changes in the midpoint were for each particular time in the market. And this is, obviously a little bit more complicated script, but it just kind of goes to show you some of the analysis that you could do. And if I look at that, what that's going to show me is essentially from the base time, so exactly when the trade happened, there was a 1 cent difference in the stop price. And then 4 seconds before the trade happened, there was a half a cent, so on and so forth. And so that kind of gives you an indication of how much the market is changing around the time that the trade was executed. And so from there, we're pushing that all into our legacy database. So we've done an initial acquisition of data, pulled data out of MongoDB, done a lot of analysis on it, and now we're pushing it into a database that we can use to manage results. And so the way that the end user is actually managing those results is through a web-based front end that we have. And from here, you can see basically all the volatility that was happening in the market, color-coded, and they can drill into any one of these particular trades and see additional details. So in this case, we're taking data that's directly out of our internal system, and and then also applying with that data directly out of MongoDB. So even from the front-end perspective, we've been able to integrate traditional legacy database data sources and integrate that directly with MongoDB. So what we just went through was a way to really take big data and drive operational processes. So in the past, this was something that the customer couldn't do because of the volume of data. It was something that would have taken them a year to take care of. And so by using these big data tools and new ways of managing data, they can take that data as opposed to using it as a byproduct and using it to actually drive their overall process. By using the Lavastorm tool, we were able to really provide complete transparency into the analysis process. So it wasn't a black box. It wasn't a complicated MapReduce job that we had to try to explain to someone in business terms. By using the Lavastorm tool, we're actually able to take that and apply it and to describe it in a way that even a business user could understand. We're able to take multiple data sources and combine that with legacy data, and big data to really provide a level of analysis and a level of insight into data that they weren't able to do if they were just looking at big data or looking at a big data tool by itself or just looking at internal systems by themselves. And then really importantly to this customer is that we're able to do it in a way that was much faster than traditional approaches. This particular problem, they were saying that it was going to take upwards of a year to solve if they were trying to do it internally.
Great. Thank you so much, Brandon and John, both. Very good presentations. We do have a little bit of time for some Q&A. During the presentations, I was taking some notes, and I want to thank our audience again for being very interactive. So I have a couple of questions that we can ask before the end of the hour is up in about 10 minutes. Brandon, the first question is for you. The attendee would like to know that you mentioned that one of the people you worked with couldn't solve the problem for a year before they started to work with you. They'd like you to elaborate a little bit on the barriers that you encountered and how you got over those barriers.
Right. So the big challenge, particularly with market data, was the volumes that we're dealing with. So you know, it's measured on the order of hundreds of millions, close to billions of records a day. And so the traditional approach that they were following would be to have this in files, maybe put partial days in a database, and then run queries or run custom jobs where they basically just sat there and would start something and let it run overnight, and then hopefully the results would match what they were trying to accomplish. So the biggest challenge was one that was just technological. So they didn't have the tools that would allow them to take advantage of the volumes of data that they had available to do this type of analysis. The second challenge was they really couldn't easily integrate these traditional data sources out of their operational stores, their trading platforms, their customer portfolio platforms, things like that. They couldn't easily take that and relate it in a way that matched exactly what it was that they were trying to do by integrating the big data, integrating the quotes and the trades that were coming in off of the market, and do it quickly enough that they could actually drive any operational process inside out of it. Right. So it was kind of a combination of the tools weren't available, and then when they were able to do the work, it took so long to actually turn around the iterations that to do what we were able to do in a couple minutes would take them a couple days just to wait for the results to finish.
Very good. Okay. Thanks, Brandon. John, we have a question for you. By the way, I want to make sure that the attendees realize that I'm sure they see this, that the screen up currently, both Brandon and John's information is available, and you can feel free to contact them following the live event today. John, the question for you is, can I be productive immediately when I start using the Lavastorm product? And how long does it typically take to become completely proficient?
Okay, I'll answer that, and then I'd love Brandon to chime in on some of his experiences. But I can say that I would say that we have all different kinds of people that that are able to take advantage of the Lavastorm Analytics engine. And in fact, what's shown on the screen here is we have what we call the public edition, which is available for free from our site, and a number of other sites. We have thousands of people literally that have downloaded the public edition and have used it from all walks of life. We have some online training materials that help them get up and running. If you're someone that is comfortable with data, especially if you're comfortable with SQL, you can begin immediately and be quite productive right off the bat. It doesn't require that level of expertise, but people that do have that love the way that they can, in their own words, twist and turn the data any way they want. We do have people that are more of a consumer of an application like the one that Brandon showed, and they themselves, even if they have no training, no data training whatsoever, including people like CFOs that are more numbers people and not data people, they're able to take models that already exist and tweak them without any training. I would say that for the average business analyst, the tool is really designed for business analysts. Your average business analyst, you're probably talking, you can be productive probably within the first few days of using the product, and probably proficient several weeks after that. But I'd love Brandon to elaborate on his experiences with that as well.
Yeah, no, that's exactly consistent with the time frames that I would have laid out, John. And I would just probably add to that. The more technical background that people have, the faster that learning curve can be overcome. So, we've taken people that are really truly business analysts, maybe know a little SQL, know Excel pretty well, and are able to get them, I would say, to the point where we can actually give them work and have them do it self-sufficiently with very, very little input in a couple weeks. On the other end of the spectrum, folks that are, are SQL experts or have some sort of programming background, we've been able to see those folks get up to speed in as little as a week and doing some things that, are very, very complex, in that if you were trying to do a traditional sort of programming or SQL-based solution would take you weeks, we're able to see them solve those kind of problems in a few days.
Very good. It's impressive. Brandon, we have another question for you while you're teed up there. Can you review what data you were using from MongoDB and what data you used from outside of MongoDB, and was it difficult to get the data from MongoDB joined together with that other data?
Right. Yeah. So for MongoDB, what we did is we loaded basically all the U.S. equities quotes and trades. So if you're trading Microsoft or IBM, that trade would have showed up in our data set, as well as any quotes that were made to either sell or buy that particular symbol. So, hundreds of millions of records a day, lots and lots of data. So that's why we put that in MongoDB. And by the way, that's also information that's not proprietary to a particular firm. Everyone in the entire financial services industry that would have access to that same data. On the other side of it, the internal data, that's actually coming out of a trading platform that basically tracks all the trades that those particular customers are making. So acquiring the data is fairly straightforward, as you saw. So it could just be a database call. It could, in the case of what we just demoed, it came to us in a Excel spreadsheet. Getting the data directly out of Mongo, we automated that process, so it's just a simple call into MongoDB. So once we got the data out, this is one of the great things about Lavastorm, is we didn't have to worry about putting it in some sort of additional data source to relate the data, to correlate it. So we're able to take what were two totally different data sources that have different column names and even different data types, and normalize those in a way that we're able to join those directly within the Lavastorm product without having to actually go through the overhead of trying to stick it in another database or writing custom scripts that would parse it and then try to relate it. So a big benefit that we saw from using Lavastorm was the ability to pull that different data together in a way that would have been very, very difficult otherwise.
Great. Okay. This next question could be either for Brandon or John. I'll let you guys decide which is more appropriate. The question is, are there any limits to the amount of data you can pull into Lavastorm from MongoDB? And if you do run into that limit, what's the best way to address, and how perhaps did you address it in your project, Brandon?
Yeah. So I'll take that, and John, you can chime in, of course. But it's a great question, and one that I think is when you're dealing with a tool that gives you a lot of power that you want to sort of try to manage. But you can get yourself in trouble, not necessarily from a technological ability to process, but just from a pure does it make sense to pull out several 100 million rows of data to try to analyze. So part of the solution that we built, we actually put a limiter in there that we could configure this as, okay, I only care about the first 10,000 rows of this data, or 10,000 documents in the case of MongoDB. Anything beyond 10,000, let's just treat it as a separate analysis process that we'd have to go through. So we built those controls to kind of keep us from getting ourselves in trouble. But from a technological standpoint, as long as you want to sit there and wait long enough, you can manage it and handle it. So, John, do you want to add anything to that?
No, I mean, I think you covered it, Brandon. I think the question was more about MongoDB support, but I guess I'd just say that we do have organizations like yourself handling quite high volumes of data. Many of our organizations, especially when they're using analytics to monitor an ongoing process, they can be looking at analytics that are processing sometimes billions of transactions on a daily basis. So we do pretty good on the volume dimension.
Great. Well, I'm going to leave that as the last question since we're at the end of the presentation. John and Brandon, thanks so much for really great presentations and some great answers to some very good questions. For those of you that did ask questions that did not get them answered, you can rest assured I'm going to be sending the entire questions, the list of those, to both Brandon and John, and they will follow up with you following today's presentation. I just have a quick announcement to make. Please mark your calendars for May 7th and our next Data Science Central webinar, which will be How to See and Understand Big Data, sponsored by Tableau. Also, as I mentioned earlier, today's taping will be available on demand in the next couple of days, both on Data Science Central and then also on Lavastorm website as well. This brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thank you to John, Brandon, and to Lavastorm for their sponsorship and insight into today's topic. My name is Tim Addison. I'm very pleased to have been your host. I appreciate your patience early on when we had some technical difficulties, and I will look forward to seeing you all again in May.